Okay, so let's do the lab on recursion. So recursion can be quite confusing when you first encounter it. It's a method that calls itself, and it uses the stack to store variables. So I think the best way to explore recursion for the first time is to implement a classically recursive problem, which is the Fibonacci number. Now, there are a ton of solutions available to this all online. This is a classic solution. So try not to, or don't Google solutions, because the learning of this lab is working through it yourself. The amount of code that you actually have to write is very minimal, which is one of the benefits of recursion. Recursive solutions typically have less code. Now, that doesn't mean they're any less complicated. Don't confuse complexity with amount of code. Right? You can have a very complex algorithm in a very small amount of code. So there's no correlation between the length of your method, your algorithm, and the complexity. So, all right. So with that being said, let's head over, jump into the code, and take a look at what we got. Okay, so Fibonacci numbers. So you can go read the Wikipedia article on Fibonacci number if you'd like, but it's pretty straightforward. This README should give you enough to understand it. Basically, the Fibonacci sequence begins with 0 and then 1, and then all subsequent values are the sum of the previous two. The first 221 Fibonacci's are, and this is directly from Wikipedia, and you can use this as testing, right? So we got 0, 1, 1, 2, 3. So F1 is the first one is 0, first one is 1, and then F2 is 1 plus 0. F3 is 1 plus 1, which is 2, so on and so forth. So hopefully that makes sense. Okay, so one of the neat things about a mathematical algorithm like this is it is prime real estate for test-driven development. It really shines here because you already have the solution, right? This is the solution that you're going for. So we can go actually write our test first and then complete the algorithm, and it really does make it easy. Trust me, it makes it a lot easier. So let's go over into the app and go to the source and we'll go to test, and we'll see fibnum test. Okay, so you can see here, well, I have actually this is old. Let's actually rerun this so it gets cleared out. There we go. So you can see all the tests pass, right? Okay, so you see I actually have two tests here, right? I have test base case, because remember recursion, you need a base case to stop the recursion, or else you're going to get a stack overflow. So I create a new fib number object, and then I calculate the Fibonacci number 0. And if I look back over here, Fibonacci number 0 is 0. So then I expect 0. Then I calculate the Fibonacci number 1, and I expect 1, which makes sense right here. Okay, so that's just that's for base cases. Then what I do is I actually I started originally to write a whole bunch of tests, but I'm like, well, what would be a better way to test this? Well, we already have all of the numbers. So what I did is I put it here in an array. So this is called an array literal. This is an array literal syntax, right? See how I have my I have an array of ints, and I'm basically declaring and initializing the array all in one shot. And that's what this syntax is, and it's called an array literal. And then what I did is I just copied the numbers from my Fibonacci from the README. I put them in there. And then I wrote a loop to say, okay, for I equals 0, I is less than expected.length, which is this is expected, okay? And I calculate I, so I calculate, Fibonacci 0, Fibonacci 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 21. I calculate this is the 21st, right? And then I just say, I capture the return, and I just make sure that whatever my calculate returns, I assert that it equals, and then I index into the array, right? So for index 0, I expect 0. For index 1, I expect 1, and so on and so forth. So on and so forth. So that's a pretty handy way to write a very compact test that will quickly iterate through a whole bunch of solutions. And so I don't have to actually copy and paste code. You see up here how I kind of had to copy and paste code? This is probably a better solution. And now on top of that, if I add in, if I subtract this, right? Look, I don't have to update my code because it all is automatically generated, right? So if I hit this again, it'll still pass, right? And I can put it back in. Okay, save it and go for it. So that's the testing. Okay, so let's go back over here and look at the source. So we have Fibonacci.java, which is the interface. Okay, so don't modify. You have to implement this interface in the fib number class, and that's pretty much it. So you got write your tests, and then implement the. I'm not going to show this because this is a solution. Implement the interface Fibonacci, and hopefully everything will go smoothly. So this is now after you've done this, you can actually claim that you've done the classic Fibonacci. In fact, in a lot of languages that are more recursive based or more functional, like Haskell or OCaml or Lisp, a lot of times the hello world will be calculating the Fibonacci number to showcase recursion. So that's all for recursion, and I hope you enjoy the lab. It should be relatively straightforward, assuming that you do the unit test first. I would really encourage you to try to do practice test-driven development. It is kind of fun to do that. So that's all I have for this. Happy hacking.